from the beginning, or I just?
No.
I'm not sure we need to do that. I just. So I was talking basically about workflows, automation, and all the kind of stuff, and I was explaining why it's actually important for cloud
Just make sure
infrastructure.
your slides are not locked.
Yeah, okay. Great.
Yeah.
Yeah, I
Okay.
think it's good.
That's good, right?
Yeah, you're good.
So, so let's continue. So,
Oh, we do need to turn on your microphone though. Sorry.
Okay.
Not this one. The microphone on hang off. Chrome.
Okay.
Yeah, but so.
Well, we engineered a
All right.
break. Whatever comes naturally works best. So.
All right, we're ready to go. Sorry for the interruption.
Oh,
Keep our friends online.
so no problems. So, what was the point where I stopped actually? So, I was telling basically, if we, for example, decide to use something like a Python to automate some complicated processes within a cloud environment, we would have to deal with tasks like how do we make sure that our process consistent of multiple distributed steps is actually durable and fault tolerant, and how do we make sure to make this state of this process observable, and how do we run this workflow, this process on a periodic basis, and so on and so forth. And so in other words, right tool for the right task. And this is where a workflow engine comes into play. And basically what workflow engine does, it just increases the level of abstraction and makes it easier to model processes consisting of multiple steps. And it allows you to concentrate on some business tasks, business needs, rather than implementation details. So, and as you can see here is the project mission I would sell for Mistral. So, and for my previous words, I think it should be pretty straightforward. It should be pretty logical who Mistral users are. So, and by the way, in addition to that, I would say, I was going to say that at some point we just decided to start this project, and there was another reason for that, and because we saw some growing demand in workflow capabilities within the OpenStack community. Now I'm also talking about projects like Nova, Cinder, Heat, and other projects like Murano and Solom, and they all have to come up with their own solutions for internal application processes automation, because they have to deal with some distribution and other stuff like that. So, because of that, Mistral users are OpenStack developers themselves, to first of all to automate their internal application processes. And it can also be system administrators who want to run some periodic helper jobs within the cloud. And it can also be enterprise application developers who want to automate some business processes which are parts of some enterprise software. And so now let's take a look at the use cases for this technology, for Mistral workflow as a service, right? We actually see currently three the most important use cases. So first of all, it's cloud crowd. Like I said before, the target audience here is system administrators who want to automate some periodic helper jobs within the cloud on multiple machines. And the second use case is deployment. For example, deployment tool like Murano or Heat or something else, or like Fuel, can actually represent the whole process as multiple steps and combine them into a single workflow and run Mistral, use Mistral to run this workflow. And the third interesting use case would be something like live migration. For this use case, we assume that Mistral can be integrated with tools like Ceilometer, so that we can say that, for example, if our CPU is close to 100%, we can just start a workflow to migrate this virtual machine. And so now I'd like to pay special attention to our cloud cron use case, because this is basically our current focus of work, so I would say. Again, the key point here is, for example, we have a cloud environment and we have like tens, maybe even hundreds virtual machines in this environment. And basically the problem is, how do we make sure we can configure, easily manage and configure and run some processes encompassing all these multiple machines and run these processes on a periodic basis. So it's basically the use case is basically what system administrators do with some individual machines using the widely known tool called cron in Unix world, right? So, but instead of dealing with all these multiple machines here, we can use just Mistral as a single point of configuration and control for all the helper periodic jobs here. So we don't need to configure all of them individually. So now let's say a couple of words about main Mistral features. So first of all, it's a web service, it's a RESTful web service, right? And is going to provide a domain-specific language to describe all these entities like tasks and some different things like events, external events. And it also is supposed to provide the ability to run tasks in synchronous and asynchronous mode. And this may not be really clear right now, but I can explain more later. So. And one more thing, which is pretty interesting in my opinion, is that actually we clearly separate two things, tasks and actions. So tasks basically is an abstraction just to concentrate on your business logic, not to deal so that we don't need to deal with some implementation details. And actually action represents some particular piece of work that needs to be done. And I'm going to show you this in the next slide. So, and one more thing about action. So action can be something like sending an HTTP signal in a simple case, or something like sending a message over AMQP protocol, or issue secure shell command or something else like that. Or we can actually implement our own action if we want to combine it into a workflow and use it seamlessly. So okay, let's now take a look at what Mistral workflow consists of. So first of all, it consists of tasks. Tasks form a graph, and each task is associated with some action. And there are two types of relationships between tasks and the graph. So first of all, transitions. It's when we basically say once task A completes in the workflow execution, we need to start task B, depending on some certain condition. For example, in case of success, we start task B. In case of failure, we just start task C, or something like that. So basically, depending on what result the task actually produced, we can make some decision and do this kind of branching of working. So, and dependency says, before we start this particular task A, for example, we require that task B is completed. And we also have to provide the capability for data transferring between different multiple tasks, because it's very important, and that's what we call data flow, and I'm going to tell you about it a little bit on the next slide, I guess. And we're also going to have in our Mistral workflows some conditional expressions, which are pretty simple, so that we can actually do some sort of smart logic, I would say. So this slide basically, I think, repeats most of the previous one. Just one thing I would like to say here is the DSL that Mistral provides is a YAML compatible format where we can declare all these things like tasks, actions, events, and conditions. So, as far as data flow, but by the way, this is our current focus of development, and we have lots of questions about and ideas how it should be implemented. So why do we need a thing called data flow, and what is that? So even if, in a trivial case when, for example, we need to create a VM, right, in the cloud environment, and then we need to do, on some next steps, we need to use this VM to do something with this VM, for example, just send an HTTP request, something simple like that. We have to create a VM and store an IP address of this VM, some sort of identifier, right? And the key point here is this information is dynamic, so we can't configure it in advance as a part of our workflow. So, and we should be able to transfer this information, propagate this information across the whole workflow, and to pass this information to the next task and stuff like that. So this is just a simple example, and we have some more complicated use cases when we need to do some sort of merging between different objects and stuff like that. So I can explain it a little bit later in details if you want me to. So a couple of words about the architecture. So this is a high-level picture of Mistral's architecture. So basically, like I said before, Mistral is a web service, and of course it has a component called API service, which is responsible for receiving HTTP request and processing them. So a typical HTTP request can be upload my workflow definition, or for example, start this workflow definition that I have uploaded before. Or I can send an HTTP request like, give me the state of the current workflow execution and all of this test. So, and the scheduler is responsible for periodic events, and engine is the most complicated component, I would say the most complex component, which is responsible for all the smart logic related with workflow execution. So basically it knows how to analyze all this graph and decide what needs to be executed depending on our dependencies or transitions, conditions, whatever. So eventually we have a component called task executor, which is responsible for eventually execution of the task, of a particular task. So as we can see here in this picture, we have two message queues, and so scheduler and API service, or actually it can be something else, we have some use cases for that too, can submit workflows into a workflow queue, and in a synchronous manner, an engine instance pulls the message out of queue and starts actually workflow processing. And what it does, at some point when it knows what tasks need to be started, it just submits them into a task queue, and eventually the task executor gets this message out of the queue again and does all the processing. And as you can see, actually, we can have multiple instances of task executor, and this is one of the points where we can actually scale the architecture, so we can shrink the number of task executors that we want to scale down, or we can just spin up more task executors if we want to. And of course, all the components work with the database where we store all this information about workflow definitions, workflow executions, tasks that are currently running, and stuff like that. So the current status of the project is we keep working on a pilot project right now, and we already have some basic model implemented, and I'm going to show you how it works shortly. So here's a bunch of links basically that you can follow to find more information about the project itself. And as far as contributors, the project started about 3 months ago by Mirantis, and recently we got some new engineers from the company called Stackstorm, and we really appreciate their pace that they started working on the project at. So, and one of the guys is right here. So, so before I show you some basic existing functionality that Mistral already does, I'm going to explain the demo scenario itself. So imagine we have a workflow consisting of 4 tasks. For example, we want to do some sort of a backup on our VM. So we have a VM, for example, and we want to make a backup. So the first task is put service on hold, so we need to make sure this VM is not serving any requests. And then we're going to back up some user data, let's say, and back up some service data. And once these 2 tasks are done, we want to, well, actually it's not really correct, but okay, so we want to make sure we end this process with something else. So this actually 4th circle is not really correct, so it should be like execute backup or something like that. It's just an artifact. So, and the idea of the application, can you hear me? Okay.
Yeah.
So, and the idea of the application is pretty simple. It's a demo scenario. So we have an application, a standalone application, which exposes a HTTP REST endpoint so that it can serve some incoming requests actually. And first of all, this application, when it starts, it uploads the workflow definition into Mistral containing this simple draft. So this is basically a diamond schema. So I forgot to mention that the 2 tasks, backup user data and backup service data, depend on the first one, put service on hold. So this is basically just a dependency model base, dependency-based model. So, and the 4th task depends on these previous 2, and here's how it works. So, when the workflow starts, every task is associated with an action sending an HTTP request back to this demo application. And demo application itself just simulates some useful work, for example, backing up some user data, right? And basically just sleeps for a few seconds, and then in a synchronous manner, it just replies back to Mistral saying, hey, okay, here's the data for, here's the result for this particular task. And the result contains the information whether it was successful or it has finished with a failure, actually. And eventually, when all the tasks are completed, the workflow is considered to be finished. So now let me switch to my window here, my IDE window. And first of all, I'm going to show you how the DSL looks like here. So, okay. I think we can start it now, right? In just a second. So this is a YAML format, like I said before, and we have a section called workflow, which basically describes all the tasks that this workflow has. And as we can see here, we have a number of tasks here, and which contain basically put service on hold, task, backup user data, backup service data, and execute backup, which was supposed to be the 4th circle in that diagram. I'm sorry for that. So, and here we see that in action, each task is associated with some action, right? And each task optionally has some dependencies. And we will also have a section called events, and here we say that this workflow execute backup should run periodically every minute. So, and here we have a section defining all our actions, which are basically just HTTP requests in our scenario. So this actions just send HTTP requests back to demo application. So let's just start our API server. Okay, it's up and running, and I'm gonna start one task executor instance. So it looks like it's ready to go, and let's start the application, demo application itself. Okay, it was able to load the workflow definition itself. So now it's about, okay, let's just wait for 5 seconds and it's gonna start again. Yeah, so as we can see, so now actually we can see that put service on hold is running. So at some point we have put service on hold success, and then we start backup service data and backup user data in parallel because they are independent of each other. And eventually at some point when they are done, we just start the final task, which can actually contain some post-processing, like send SMS message to a system administrator or something like that. So, and it's going to be repeated every minute. So this is just a quick example just to show what currently Mistral can do. Okay, let me just go back to my presentation. Okay, so this slide basically shows the information about our current vision on Ice House roadmap. So we're targeted to finish pilot project by the end of February. This pilot project is going to contain all these main capabilities I mentioned before, like transitions, dependencies, conditional expressions, and cron events and stuff like that. And it's going to support Keystone integration. By the way, I forgot to mention this example that I showed before. It works without actual OpenStack installation. It's just a pure model just to demonstrate some basic capabilities. And after that, we're going to start working on release 0.1, which is going to include some more advanced functionality. So we have a lot of blueprints actually captured in our project Launchpad page. And so everyone is welcome to contribute, and the simplest way, I think, even for you to contribute into this project is just to share your experience of working with similar technologies, maybe share your ideas that you have about workflow automation and workflow engines. And so there are many ways how you can contribute and influence the direction of this project, right? Like Alex said before, the future of OpenStack is in your hands. So, and this technology, Mistral, is not an exception from this rule. So, and this is pretty much simple workflow of how you can become a Mistral contributor. And I believe most of you have already completed parts of this step. And once you get into this loop, basically, you're a Mistral contributor. So you're welcome to contribute, and should be pretty exciting, I think. So here are my contact details, and that's it. I'm ready for questions. Yes.
Thank you.
Okay.
Nothing personal, but I've worked with workflow people for off and on for 15 years, and every one of them ignores transactions.
Mm-hmm.
They don't like transactions because transactions are hard. I was pleased to see you have rollback as a to-do.
Yeah.
I'm very sad to see you did not start with rollback.
Okay, so. Well, actually, I was expecting the question, I think, and that basically we have this on a roadmap. That, like I said before, the project is like 3 months old. So, but I can say, for example, if you want to add some transactional behavior into workflow processing, you should keep in mind that not everything depends on the workflow engine itself, right? Because we can only guarantee that we can roll back some certain steps in the workflow, and it depends on some action handlers in our case, how we call them, right? How to react, how to process this rollback behavior, right? So, but we definitely can do something to make it happen.
More questions, please?
Coming back to the use case you demonstrated, that is more like a live migration except for the incremental update, very similar to that. But what I wanted to see was what is the correlation between the Mistral and the Murano? How do you take a use case of Murano and implement it?
Yes.
Because that will give us more insight into the API of the task, add, delete, whatever.
Yeah, right.
And so those things.
Yeah. Okay, I see your point. So, basically, what's happening right now is Murano DSL is not really stable, and Mistral's DSL is now not really stable. So we're currently working on both DSLs, I would say. So it's kind of challenging, you know, to start using Mistral and Murano right away, because it's not really mature, and they have their own goals, even though most of the people, I guess, from the same companies, these are completely different projects, and they aim actually a little bit different goals. But at some point, Murano has its roadmap to get integrated with Mistral, and actually we consistently keep in touch with them to collaborate and make sure we're moving into the same direction.
No more hands? Raise a hand. Okay.
I have two questions. The first is, I'll just blow up both questions, you can answer in your order. The first is if you can talk a little bit about the kind of the technical engine underneath there, with what are the technologies running on message queues, databases?
So currently we're using RabbitMQ, and the database is going to be MySQL for now.
Okay, so right in line with Python, I mean with OpenStack.
Yeah, we were thinking about some NoSQL solutions because they look like a good fit in our case, because we deal with some DSLs, and it could be really good to use something like MongoDB, for example. But just for now, for pilot purposes, we just decided not to go in this direction and simplify things a little bit.
So a follow-up on that then is that most of the workflows that aren't solved by scripting in our world are actually multi-data center workflows. And so some of the questions about MongoDB, MySQL, both of those are hard to distribute.
Yeah, right. So you're completely correct, and this is one of the things where we keep thinking about. So, right.
So ideas well.
Okay. The second question.
Share your ideas how to distribute the state somehow.
Awesome. First, so the other question has to do with security, access controls, how that auth model works. In particular, given that Keystone is fairly coarse grained, we don't have things like RBAC from AIM, for example.
Okay, so one of the problems we have to think about is, for example, when we upload some workflow definition that sends some request to Nova, for example, we have to have some authentication tokens to be able to do all these operations, right? But for example, when it comes to periodic execution of these workflows, we'll have to deal with the problem of authentication token expiration, so because they're not long-lived, so we have to use something else, right? And for now, actually, we have some pieces of code integrated into a project that work with trust mechanism exposed by Keystone, so that we can basically impersonate the access that the initial user has, right? And to be able to use it on a later stage, so like in 1 day or in 1 week or something like that. And we have this code integrated, but it's not fully tested yet, so we'll keep working on that.
So my question is, why did you choose to develop a workflow engine? I mean, there are many workflow engines out there, open source and proprietary. Every other company has one. Instead of, for example, what we do in Cinder and others, just provide the API and interface to an existing industry standard workflow engine, and then you kind of not taking it on yourself to develop everything from scratch, which is available.
Right, so the answer to this question would be we want to make sure that this technology is going to be really helpful for OpenStack infrastructure, for OpenStack community, and so that it gets integrated into this infrastructure seamlessly. For example, we had an idea to start with something like BPL, and actually when we had a closer look at this like industry standard, like you said, we just made sure it's never gonna work in OpenStack. Maybe not never, but it's very complicated, in other words. So we just we want to believe that we can produce something much simpler that would fit our current needs and maybe some needs that we will have like in 1 year or in 2 years. So for example, BPL is just really complicated.
Okay, so you didn't make sure, you became sure, right? That what?
Yes, right.
What prevents you from using a workflow engine within the state machine, state engine? And just leave the API above and use any engine, you can have any option.
Well, yes, we can do that, I think, but actually, as it turned out, the internals of this distribution and all kind of stuff is not really complicated, but at the same time, once we decided to build something from scratch, we're going to have more control over all this behavior, and we can tune the technology better to some particular scenarios that are relevant for OpenStack infrastructure. So, like you, I think you were able to see that something was already working and is distributed and is scalable. That example that I showed you before, we were able to produce like in a couple of weeks, seriously. So what we're doing right now is goes far beyond that simple example I showed before. So.
I think there is also, I mean, this goes back to the same philosophy that we discussed in the Murano's case, that when you build a full stack of things, workflow is a very fundamental building block that will be reused in the stack up and down, and the value of it is to be really tightly integrated natively with the components of the kernel of OpenStack. And that will end up being the differentiation. Those components that are tighter integrated and can be reused by others will survive. And to that question, I mean, if you take conceptually, it's not the same example, but conceptually, if you take an example of running native paths versus a Cloud Foundry, they both work, but there is a reuse component. Same scheduler, for example. Why have it twice? Or some other important components that kind of duplicated in two projects create complexity that will make it, in the end, efficiency is not going to be as well run, and tuning of it is going to be a much more difficult problem. So I think for these types of building blocks you have to think of them natively in the context of OpenStack proper. And then once those building blocks are there on the application side and other things that are less specific to the kernel, I think we'll see a lot more reuse of third-party components. General philosophy.
Completely agree.
All right, no more hands. So it's 9 o'clock, so we're 2 hours into it, and it looks like we're done.
Yeah, thank you
So
very much.
thank you everybody for coming.
So thanks for coming to Yahoo, guys. We have meetups, regular scheduled meetup. This is a little bit outside of the normal cadence, which is totally cool. But we have monthly beginner meetups. If you guys want an overview of architecture, come here tomorrow night. It's also on the same OpenStack feed you'll see on meetup.com. And we also have a bi-weekly, twice monthly hackathon that happens to occur tomorrow night as well. So all is welcome. Have any questions, just post it on the meetup page. I'll be happy to answer your questions. Thanks for coming.
Slides link on the meetup page?
Sure.